Swayam Prabha. Digital India. Educated India.
Hello all, welcome back. In the previous lecture we were discussing about different evapotranspiration equations. Different equations which are used for estimating evapotranspiration. So today let us solve one numerical example related to Penman's equation. So let me read out the question first. Estimate the potential evapotranspiration using Penman's formula. Required data are given below. You know, Penman's equation is actually a very simple equation, but in that one particular term is there corresponding to net radiation. If net radiation is given to you in the question, it can easily substituted in the Penman's equation and we can easily calculate the evapotranspiration. But in case this Rn value is not given to you, you have to make use of the lengthy equation which is provided by Penman's method for calculating the net radiation. So here the data given are latitude 22 degrees 18 minutes and elevation 270 meters above mean sea level, mean temperature 20 degrees Celsius, mean relative humidity 80%, mean observed sunshine hours 8.5 hours, wind velocity at 2 meter height is 70 km per day, nature of surface cover close ground green crop, psychrometric constant 0.49 millimeters of mercury per degree Celsius, actual duration of bright sunshine in hours is 9 hours, maximum possible hours of bright sunshine which is a function of latitude is given as 11.1 hours. Mean monthly solar radiation at top of the atmosphere Ra is given as 9.51 millimeters of water per day. Reflection coefficient or albedo is given as 0.25. So from the data which are given to us, it is very clear that we need to calculate the Rn value. Directly net radiation is not given to us. So let us start solving the example. Penman method gives the potential evapotranspiration by using this formula. That is delta Rn plus Ea gamma divided by delta plus gamma. In this, PET is the daily potential evapotranspiration in millimeters per day. Delta is the slope of vapor pressure, saturation vapor pressure curve that can be calculated by using this formula. This formula is familiar to you. When we were discussing about the water vapor dynamics, we have seen different parameters related to atmosphere and those values calculated by using different formula. And at that moment we were discussing about the saturation vapor pressure curve, and delta is the slope of the saturation vapor pressure curve. And in this we are having a term ES. ES is representing the saturation vapor pressure in the air in pascals, and T is the temperature in degree Celsius. Other term is EA. EA is the parameter which incorporates the saturation deficit and wind velocity. EA is given by the formula 0.35 1 plus U2 divided by 160 ES minus EA. So ES minus EA is representing the saturation deficit, how much extra water vapor can be added to the atmosphere. That component will be coming into this particular term ES minus EA. Then first term is 0.35 multiplied by 1 plus U2 divided by 160. What is U2? U2 is nothing but the mean wind speed in kilometers per day and what is the location which is measured is 2 meters above the ground surface. 2 meters above the ground surface, what will be the wind velocity, and unit is in kilometers per day. ES is the saturation vapor pressure in the air in millimeters of mercury. So, you need to be careful here. Two equations are coming. When we were talking about delta, that is the gradient of saturation vapor pressure, in that ES is substituted in pascals. In the case of calculation of vapor pressure deficit, that is saturation deficit, we are substituting the ES in terms of millimeters of mercury. Now, EA is the actual vapor pressure which is prevailing in the atmosphere, that also should be in the unit of millimeters of mercury. Gamma is the psychrometric constant which is present in the PET equation. So, I think we have covered all the terms except Rn. So, delta Rn plus EA gamma divided by delta plus gamma. Now, let us look into Rn. Rn is the net radiation in millimeters of evaporable water per day. So, this is representing the net radiation. Related to this net radiation, how can it be obtained, that we have seen in the previous lecture by making use of an expression. So, that expression is given by this equation. Now, we will calculate different parameters one by one. PET is given by delta Rn plus EA gamma divided by delta plus gamma. So, EA is given by the formula, and in that we need to calculate ES and EA, that is saturation vapor pressure and the vapor pressure present in the air corresponding to that particular temperature. U2 is already given to us, wind velocity at 2 meters above the ground surface is given to us. So, first let us start with the calculation of ES. Saturation vapor pressure can be calculated by using the formula. The relationship between temperature and saturation vapor pressure is known to us. In that we need to substitute the temperature in degree Celsius. So, temperature is given as 20 degrees Celsius, and when we substitute that in this equation, we will get ES as 2339.1 pascals. So, this equation is giving us the vapor pressure or the saturation vapor pressure in pascals, but we need the value in terms of millimeters of mercury. The value which we are substituting in Penman's equation is in millimeters of mercury. So, we need to convert this value into Pascal value into millimeters of mercury. So, we know the relationship between pressure and height, that is P is given by rho GH. So, here we need to get the value in terms of H, depth of mercury. So, that can be obtained by P by rho G. We know the density of mercury and G value also known to us. So, that we can substitute over here to get the value of ES in terms of millimeters of mercury. So, it can be calculated as 17.53 millimeters of mercury. Now, next is EA. Second term is EA. So, for that we are having the knowledge about the relationship between vapor pressure and saturation vapor pressure. That is from the knowledge of relative humidity. Relative humidity is the ratio of vapor pressure to the saturation vapor pressure. So, EA can be calculated as RH multiplied by ES. RH is already given in the question, ES we have already calculated now. RH is 70%, so we can get EA as multiplying it with ES. So, we are multiplying and we will get the value of actual vapor pressure as 12.27 millimeters of mercury. So, in this equation for calculating EA, we are having everything U2 given, ES and EA calculated. So, we can calculate EA by substituting these values. U2 is given as 70 kilometers per day. So, when we substitute that, it is coming out to be 2.65 millimeters per day. So, the value corresponding to the parameter EA is 2.65 millimeters per day. Now, next term is delta. that is gradient of the saturation vapor pressure curve. So, that can be, we are having the expression corresponding to that. ES we have already calculated and we are having temperature. So, here we need to substitute that and the value is calculated to be 144.79 pascals per degree Celsius. Here also we need to convert it in terms of millimeters of mercury by using the same formula. We will be dividing it by rho g, that is calculated as 1.086 millimeters of mercury. We are just dividing this value which is in pascal by density rho g. Density of mercury is 13.6 and g is 9.81. So, delta value is also obtained, EA is obtained to us, psychrometric constant is given to us and now we need to calculate the value corresponding to net radiation. So, net radiation is given by this lengthy equation. So, here different values are already given to us, just we need to substitute in this and get the value corresponding to Rn. What is the value of Ra? Ra is given as radiation at the upper layer or outside of the atmosphere. It is given as 9.51 millimeters of water per day and R is given as 0.25, that is we are having the grass crop which is given on the surface. So, from that surface how much will be the reflection taking place? That value is given as 0.25 and A can be calculated by making use of the latitude of the area 0.29 cos phi. So, this is calculated as 0.2683. Next term is B, that is the constant for every word, that is 0.52. Now, we need to calculate the values of n by n. We need to calculate the ratio of n by n. Small n is given as 9 hours and capital N as 11.1. So, for these different standard tables are given in textbooks. Depending on the temperature and the latitude, we can get the values corresponding to sunshine hours. Maximum sunshine hours for a particular day will be given to you and how much is the mean sunshine hours, that can be obtained from the table, and these standard tables can be utilized if data is not available, measured data is not available to you. Sigma is the Stephen Boltzmann coefficient, that is 2.01 into 10 to the power of minus 9 millimeters per day. Temperature should be in Kelvin. So, 20 degrees Celsius is the temperature. So, that is converted into Kelvin. So, we can calculate sigma Ta to the power of 4, that is coming out to be 14.8. Now, we are substituting in this equation of Rn. Rn value can be calculated as approximately it is coming out to be 2 millimeters of water per day. So, Rn is equal to 2 millimeters of water per day. Now, we are having all the values corresponding to the parameters which are present in the Penman's equation. So, just we need to substitute in Penman's equation delta Rn Ea gamma delta plus gamma. All these values are known to us. So, it is given over here, just substituting in the potential evapotranspiration equation to get the value. It is calculated as 2.202 millimeters per day. So, potential evapotranspiration from a particular location for a particular month can be calculated as 2.202 millimeters per day for the given data. And in this equation, just we need to consider the latitude of a particular area, and based on that and a particular duration on which we are going to, particular day or month on which we are calculating PET, standard tables can be referred from textbook and corresponding values can be taken, and after substituting in this we can calculate the potential evapotranspiration. So, different formulae we have seen in the previous lecture. If the values are given to you, just substituting in those equations and calculating the values corresponding to potential evapotranspiration. So, I am not going to do all the examples. you can get different types of examples related to all the formula in different textbook. I have referred this particular textbook for this textbook by Engineering Hydrology by Professor Subramanya for related to this particular topic. So, you can work out different examples from different textbooks. Thank you.